Welcome back. In this video, we're going to go over how to solve inequalities, and we're also going to go over how to find slope from lines that we're going to do. So first off, how to graph the inequalities. We're going to graph them on a number line, and you're going to have to match them up or figure out what the correct graph is. So inequalities means that something is not equal. And so this first one, this symbol right here, means less than, so we read this as x is less than 2. And so when we graph this on a number line, we want to show all the numbers that are less than 2. So of course, now all the numbers here to the left, -1, 0, 1, a half, all of them up to 2, but doesn't include the 2. Since it doesn't include the 2, we're going to put an open circle on the 2, and we're going to shade everything to the left. And it goes all the way to the left. And sometimes we put this on the number line. Sometimes people like to put it on top of the number line. Either way is fine when you're doing your homework. The next one reads x is greater than 2. So this is the greater than symbol. And that means, again, we're going to have an open circle because it's not equal to 2. And this time we want all the numbers that are bigger than 2. So 3, 4, 5, 6, pi, all the numbers to the right of 2. Now, an easy way to remember this is, like, let's take two numbers here, 2 and 4. If we want to compare them, we would put this symbol. Some people say that this symbol looks like an alligator or a Pac-Man symbol, and it's always going to go for the bigger number. So the big side here is going to open up to the bigger number, and the pointed side, the small side here, is going to aim towards the lower number. So this would be 2 is less than 4. Another thing is, you know, you might think that this looks kind of like an L, just kind of folded up a little bit to help you remember the difference here. The third one here, this has a line under it, so this is going to be less than or equal to 2. So less than or equal to 2. And how do we show that? Well, again, we're going to go to 2 here, but this time we're going to put a solid circle in. And again, we want to shade everything to the left. So all these numbers to the left would be shaded. And the last one, of course, is greater than or equal to. Because again, the line here tells us that we are equal as well. So this one would have a solid circle on the 2 and shaded to the right. So that's how we graph inequalities. And now we're going to solve inequalities. And we're going to solve inequalities the same way that we solve equations, except we've got these two exceptions. Number one, when we multiply or divide both sides, I should say, by a negative, we're going to end up flipping the sign. So I'm going to do two examples here. So say, you know, we've got 2 is less than 4. That's a true statement. But what happens if I multiply both sides by a -1? This becomes -2, and this becomes -4. But now the inequality sign would flip, and -2 is bigger than -4. And the reason for this is because when we multiply by a negative, it's like we're going to the underworld, the other side. And here's 1, 2, 3, 4. When we go to the other side, everything gets flipped. So we got -1, -2, -3, and -4. So when we multiply both sides by a negative or divide both sides by a negative number, basically we're flipping over to the other side. If we're on the negative side, we're flipping to a positive. Positive, we're flipping to negative. And the order of those values is going to get reversed. And another example from algebra, let's just say we have -2x is greater than or equal to 6. In here I want to solve this for x, so this means -2 times x. To get the x by itself, I would just divide both sides by -2. And when you divide both sides by a negative, again, you have to flip the inequality sign. So we have x is less than -3. When we do that on a graph, here's 0. Then we got -1, -2, -3. There's -3. And then when we graph that, it's going to be everything to the left of -3 with a solid circle. And so if you wanted to test this, you could put in one of these numbers, like -4. And if we go back here to the original and put in -4, we should find out that it is true. So -2 times -4 is 8. 8 is bigger than or equal to 6. So it checks out. So there's a way you can check your solutions when you find these. Just take a number that you shaded and plug it back into the original. Another exception when dealing with inequalities that we have to remember is if we ever have to flip the inequality. So, we had 2 is less than 4, but if I flip them around and put the 4 on the left side, now we'd have 4 is greater than 2. And when we're doing this algebraically, we might have something like 3 is greater than x. And we might want to flip this around so that the x is on the left side because it's easier to read, and then put the 3 on the right side. And when we do, it's going to be x is less than 3. When we have it in this order, it makes it a lot easier to graph. So when the variable is on the left side, then it's easier to read. We have x is less than 3. So we go to the 3 here, and notice that this looks like an arrow, and that's going to tell us the way we're going to shade. But that's only going to work if the variable, again, is on the left side. So it's easier to read your solution and to match it up with the graph or to graph it if the variable is on the left side. So you might want to flip the inequality sometimes. If your variable ends up on the right, you got to flip it over to the left, and remember to flip the inequality sign. And then the other steps are just like solving the equations that we dealt with last time. So we still go through all 5 of these steps, simplifying both sides by combining like terms or using the distributive property. When we do that, it's not going to change the inequality sign. When we are moving variables around, and we're doing that by adding or subtracting, it's not going to change the inequality sign. When we move the constants around by adding or subtracting, it's not going to change the inequality. Only here at step 4 do we have to make sure that if we divide by a coefficient and it's a negative coefficient, if it's a negative, what does that mean? That means we're going to have to flip the inequality sign. So if you divide by a negative coefficient, you're going to flip the inequality sign. And then make sure to check your solution. All right, so here's some examples. And usually with these problems, what you see on your quiz and what you see in the workbook, they're going to give you a number line. So that's going to make it a little bit easier because you should end up with something that you can graph on this number line. Like if you get an answer like x is less than negative 12, that's not on the number line. So you know that that's not going to be correct. Or you get x is greater than 2. That's not here. So that helps you to kind of figure out if you did it correctly. So let me copy this over. And we want to solve this for x. This is just a simple equation. Here's the x, and it's got minus 12, so we have to add 12 to both sides. And it gives us negative 8 is greater than or equal to x. But remember, sometimes it's easier to read when the x is on the left. So I'm going to switch the sides here. And that means I also have to flip the inequality sign like this. So we have x is less than or equal to negative 8. And we're going to graph that and shade everything to the left. For number 3, again, you could do this a couple different ways. Let's start by distributing. So if we distribute the negative 4 times 10 is negative 40. Negative 4 times b is going to be minus 4b. And that is less than or equal to negative 96. And now we got our b's over here on the left side. And we got a constant. Since the b's are already all together, we're going to just add the 40 to both sides. Add 40 over here. That's going to give us negative 4b is less than or equal to negative 56. And the last step is to divide by negative 4. Divide this by negative 4. Since we just divided by negative, we're going to have to switch the sign. And let's see, negative 56, that's 8 times 7, so that's 4 times 14. And so when we divide by negative 4, that should give us a positive 14. So we have b is greater than or equal to 14. That's on our number line here. So let's put a closed circle there. And it should be all the numbers bigger than it. And we can, if we wanted to, we can check our answer as well. So let's say we say, okay, 15, does that work? If I put it back into here, 10 plus 15, multiply that by negative 4. Is that going to be less than negative 96? Well, over here, we're going to have negative 4 times 25, and that's going to be a negative 100, and that's definitely smaller than negative 96. So we know that we've graphed it correctly and solved it correctly. For number 5, here we've got variables on both sides and we've got constants on both sides. So let me rewrite it. 13 plus 2x greater than or equal to 1 plus 4x. And let's see, let's move all the x's together. Now you could move them to the left, or you could move them to right. Since it's easier to read inequalities when the variable's on the left, let's take these guys over, like so. And that's going to give us 13 minus 2x is greater than or equal to, so we don't change the inequality sign. We're only changing the inequality sign if we flip the inequality or flip the sides, or if we multiply or divide by negative on both sides. And so here on this side, we're going to have a 1, and then we're going to subtract 13 from both sides. That's going to give us negative 2x is greater than or equal to negative 12. Divide by negative 2, divide by negative 2, we get x. Now we need to switch the inequality sign, so we get x is less than or equal to 6. And yep, 6 is there, right in the middle. We want all the numbers that are less than 6, so it's going to be shaded to the left. Again, if we got the x on the left, then this is going to point to the direction that we need to shade. All right, so a few more examples. So number 2, here we've got 42. 42 is less than negative 14n. And we got all the n's here on the right side. So a couple things we could do. Let's just get the n by itself here first. Divide both sides by negative 14. 42 is 6 times 7. So that means that if we do times 14, that would be 3 times 14. So 42 divided by negative 14 is going to be negative 3. And since we divided by negative, we should be flipping this. So we're going to have negative 3 is greater than n. And like I said, it's easier to read, though, if we put the variable on the left side. So we're going to have n is less than negative 3. Since it's strictly less than, that means we're going to have an open circle. It's not equal to negative 3 here. There's no line under it. And we're going to shade everything to the left. So there we go. And number 4, again, we've got the variable here on the right side. Now, again, similar to what we did above, but this time let's just switch the sides around right away. So we could flip these, and we could write this as 1 plus 3x is less than negative 44. So we could flip the sides first instead of doing it at the end. And then we could subtract 1, subtract 1. That gives us 3x is less than negative 45. If we divide by 3, we're going to have x is, now we don't need to flip the inequality sign here because we divided by a positive. So we're just going to have x is less than negative 15. And that means an open circle, and it means everything to the left is going to be shaded. And again, if you wanted to check, what we could do is take a number like negative 16, any number that's been shaded, and plug that back into here. And if I put negative 16 in here, negative 16 times 3 is negative 48. Negative 48 plus 1 is negative 47. That's smaller than negative 44. Or negative 44 is bigger than negative 47. So that does work. If we shaded the other way, we'd find out that it's not true. And we realize that we made a mistake. Okay, number 6, for this one, it looks like we need to simplify it first. So we can combine like terms here. We got 1p minus 7p, that's going to be negative 6p's, minus 8 is greater than negative p minus 13. Move all the p's together, so we'll add p to both sides. That gives us negative 5p minus 8 is greater than negative 13. And then we can add 8 to both sides. That's going to give us negative 5p is greater than negative 5. And then divide by negative 5, divide by negative 5. Since we divided by negative, we got to flip the sign. So we're going to have p is less than 1. So it's open circle and shade to the left. All right, so that should be pretty good for solving inequalities. Let's go on to the next thing. The next topic I want to talk about is slope, or it's also called rate of change. This has to do with the steepness of a line. So, when we start graphing lines, some lines are going to have a steepness to them. Imagine if you're walking up a hill, This hill might not be so bad, but this hill is going to have more slope. So a slope is going to be a ratio or like a ratio that's going to help us to measure the steepness of it, and a ratio or fraction, and it's going to be the rise over the run. So that also means that horizontal lines are going to have zero slope, and vertical lines are going to have undefined slope. And slope and rate of change is something that you use all the time. Here's a graph that shows the national supply and demand projections for registered nurses 2000 to 2020. Now I know this is a little bit dated, but just helps you out here to see that we see the demand curve going up a little bit steeper, and the supply curve here during 2000 to 2008, it looks like it has a positive slope, and then it starts to level off. Here would have a zero slope, and then here towards the later 2020 and so on, it looks like it's actually going down. So the supply is falling, and here we would have a negative rate of change or negative slope. So this is to show you that when you're looking at graphs and you're looking at prices and things like that, slope and rate of change are something that you use all the time, even if you don't realize it. And so we can have 4 different types of slope. So when you are reading a graph, you're reading it left to right. So I always imagine that there's this little guy that likes to go onto the graphs, onto the functions. Sometimes I call him Bob. And Bob always starts from the left side, and he always travels from left to right. And so if he's going up this line, you can see he's going to be going uphill. It's going to have positive slope. Whereas if he goes this way, it's going to have negative slope. If he's walking across this horizontal line, it's going to have zero slope. And if he runs into a vertical line, well, that's going to be undefined slope. He's not going to be able to really run or go anywhere, and it's going to be almost impossible to climb. If we go back to our graph here, if you have a graph like this of something over time, on no graph are you going to see a vertical line like this, because that means that it takes on several different values at the same time. So, for instance, the supply of nurses can't be 2 million, 5 million, 1 million, and so on. It can't be multiple values here on 2020. So that's why it's also undefined. It doesn't make sense for functions to have vertical lines. So we say that they have undefined slope. And how do we find it? Well, here is our graph. And let's say you're given this as your graph. Now what we're going to do is we're going to take 2 points, and you want to look at, where they seem to cross the boxes. So maybe we take this point right here, and we take this point right here. And just like we did for the midpoint and the distance formula, we're going to make this into a triangle. So we're going to draw a horizontal line, and this is going to be our run. And we're going to draw a vertical line like this, and this is going to be our rise. Now, slope is rise over run. So we can figure out what the slope of this line is after we've drawn this. So what is the rise? Well, we just count the spaces here. And how many do we have going up? 1, 2, 3, 4. So the rise here is 4. And how many, if we start over here, how far is it going? 1, 2, 3, 4, 5, 6. It's got a run of 6. And when we're given slope, we're going to write it as a fraction and make sure it's reduced. Now, if it comes out to a whole number, we're just going to write the whole number. Like if it came out to 6 over 2, we would just write 3. Here, we're going to write 2/3. So 2/3 is the slope of this line. When we go in the positive direction, then it's going to be a positive number. And if we go in the negative direction, it's going to be a negative number. So, if we start from this point, we would have to go up 4. Going up is positive, and we would go to the right 6. Going to the right is also positive. So it would be 4 over 6. But notice that we could also start from this point over here in the right, and we get the same answer. In this case, if we're going from the right point to the left point, we would have to go down 4. But then when we get to the bottom here, we would have to go to the left 6. And if we go to the left, that's in the negative direction. So the positive direction for the x is to the right, the negative direction is to the left, and for the y's, if we're going up, we think of that as positive, and if we're going down, we're going to think of that as negative. And notice this reduces to 2/3. So 2/3 means we could actually just go up 2 over 3. There's another point, up 2 over 3. So once we figure out the slope, we should be able to repeat that pattern and find other points that are going to be on the line. Up 2 over 3, there's another point. So we pick out 2 points. We can count the rise, count the run. If we're going up, that's positive. If we're going to the right, that's positive. If we go down, that's negative. If we go left, that's negative. Here's some more examples. Let's find the slopes of these lines. Now, when you're doing these, you should already have in mind if it's going to be positive, negative, 0, or undefined. So for number 1, first off, do you think it's positive, negative, 0, or undefined? Well, if you said positive, you are absolutely correct. And again, it doesn't matter. It's got the points here marked for us already, so we don't have to find them. Let's start from this point, and we're going to go up 1, 2, 3. So that's our rise, and then we're going to go over 1, 2, 3, 4, 5, 6, 7. So here we're getting a slope of 3/7. It doesn't reduce, so we're just going to leave it like that. For number 2, let's start again here on the left. This time we're going to go down 1, 2, 3, 4. So it's going down 4, that's the rise. The run 1, 2, 3. Which we're going to write as negative 4/3. Notice that if we started from this point, we would be going up 1, 2, 3, 4, but then we would go left 1, 2, 3, and we get the same thing. Negative 4 over 3 is the same as 4 over negative 3, which is the same as negative 4/3. Number 3, does it have positive slope, negative slope, or undefined, or 0? Again, it's got positive. This one's only going up 1, so that's the rise, and it's going over 1, 2, 3, 4, 5. So the slope here is 1/5. And what about number 4? Well, here, to go from the left point to the right point, the rise, it's not going up at all, so it's a rise of 0. And the run, it's only going 1 space over, so 0 over 1, which again comes out to a whole number, so we're just going to reduce it. So if it comes out to an integer, reduce it down to that integer. If it comes out to a fraction, make sure it's simplified. And we're not going to write mixed numbers or decimals or anything like that. So just keep in mind, when we are writing slope, we want to write it as reduced fractions, like 2/3. That's a good way to write it. 3/2, that could be a fraction. It could be a negative number like negative 2. So those are all good ways of writing the slope. And these are bad ways. So we're not going to write slope with decimals. We're not going to write anything like 0.5 over 2. We're not going to write something like 1 1/2. Okay, we're not going to write mixed numbers. We're not going to write a negative 2 over negative 4. We're not going to put in 2 negatives there. So this one could just reduce to 1/2. Okay, so no, when you're writing slope, we don't want to do it this way. No decimals, no mixed numbers. It should only have one negative sign. It should be completely reduced. You can leave it as an improper fraction, or you can leave it as an integer if it comes out to an integer. And that's how you should be writing your slope. All right, a few more here. Let's go through the ones here on the left here, and let's go through the ones here on the left side. So for number 1, it's going down 1 to the right 1. So down 1 to the right 1. That would be negative 1 over 1. Which we're just going to write as negative 1. So again, you want to simplify your answer. For number 3, goes up 1, 2, 3, 4. So it's got to rise at 4, and then it's going over 1, 2, 3, 4, 5, 6, 7. So it looks like it's 4/7. For number 5, the rise is 1, 2, 3, 4, 5, 6, but the run is 0. 6 divided by 0, you can't divide by 0, so this one is undefined. So this one is a vertical line. I usually just abbreviate undefined like this, so undef. And that's how we find the slope from a graph. Now we're also going to find the slope from a formula. So find the slope through the points. And what is the formula for slope? Slope is rise over run. Here is the formula. It's going to be y2 minus y1 over x2 minus x1. So just like with midpoint and distance, you first want to go up here, label your points. Let's go up here. Let's label this x1. This is our y1, x2, y2. And we're going to plug these into our slope formula. So we're going to take y2, which is 12, minus y1, which is 11. And we've got x2 is 7, and x1 is 0. Reduce, we get 1 on top, we get 7 on the bottom. It reduces to 1/7. Okay, so the answer to number 1 here would be 1/7. All right, number 3, another example here. We're going to label this x1, y1, x2, y2, and we're going to find the slope with these lines. So what's going to go on top? Well, -5 is going to go on top, minus a -10. And what's going to go on the bottom? -3 minus a -12. So you got to be careful with these minus signs here. So, 2 negatives become a positive. 2 negatives here become a positive. What do we got on top? We get 5. And what do we got on the bottom? -3 plus 12. That comes out to 9. So it looks like we have 5/9 for our answer. So you can see that this slope formula helps you out so you don't have to plot these points. It makes it a lot easier. Now, if you wanted to, you could go ahead and graph these and still count the spaces, but we have shortcuts in math, and this is one of them. So this is going to let us to find the slope. It's rise over run, so it's the difference in the y's over the difference in the x's. The top number tells us how far up and down it's going. The bottom number is going to tell us how far left and right it's going. All right, the last thing we're going to cover today is how to find the slope from the linear equation. Now, starting next time, we're going to start graphing these as well. So we are going to think of linear equations in the form of slope-intercept form, which is y equals mx plus b. Y and x are going to be our variables. M is going to be some number, and b is going to be another number. So we might have an equation like y equals 2x plus 4. And this gives us a rule for how x and y are related. So it's just saying, okay, take any x, multiply by 2, add 4, and that's what y is going to come out to. And when we have an equation in this form, y equals mx plus b, m is going to tell us the slope. And b is going to give us the y-intercept, which is going to help us to graph it in our next quiz and lesson. So for example, if we have y equals 2x minus 3, what's the slope going to be? The slope here is going to be 2. And if we have y equals negative x plus 2, then the slope here is going to be -1. If we have y equals 1/2 x, the slope is going to be 1/2. If we had y equals, let's say, 2, what's the slope? How many x's do you see? There's no x's here. The slope is 0. So if it looks like y equals a number, then the slope is going to be 0. That's going to give us a horizontal line. And if we have x equals a number like x equals 2, well, we're going to find out that that is a vertical line. So if you have just x equals a number, you're going to have a vertical line. And it's going to be slope is undefined. So again, the slope is just going to be the coefficient in front of the x. So when you write this, you're just going to write slope equals -1/2. Slope here equals -1. Slope here equals 2. Pretty easy. But let's say that the x is not by itself. So these are not in slope-intercept form. These are in standard form. And so we want to solve these and get the y by itself. So to get the y by itself, we're going to do couple steps here. So first step is going to be to add or subtract, usually subtract, but let's say add or subtract the x's to the other side. To the other side. And then step 2 is going to be to divide by the coefficient of y. All right, and this is how it's going to work. So let's say we start with 7x plus 2y equals -8. Now watch this. I'm going to subtract 7x from both sides, but I left a little space here, okay, on the right side, so that when I put the -7x here, I'm going to put it out in front. Because remember, my goal is to make it look like this, where the x's are going to come first, and then the constants come at the end. So I'm going to write that down. These are going to cancel out. I have 2y equals, bring this down, -7x. Notice these don't combine because this has an x with it, and this is our -8. Now I divide everything by 2. So make sure you're dividing both terms here by 2. And what that's going to give us is y equals -7/2 x minus 4. Now we can find the slope because the slope is going to be whatever's in front of the x. So the slope for this one is going to be -7/2. Okay, let's try another one. So let's erase this guy. All right. And what do we got here? 4x plus 3y is equal to -3. So again, maybe I'll leave some space here, put the -3 over. I'm going to first subtract -4x from both sides. That's going to give me 3y is equal to -4x minus 3. Divide everything by the coefficient in front of the y. That's going to give me y is equal to -4/3 x minus 1. And right now we're focusing on the slope, but eventually you want to make sure you have the whole thing correct because we are going to graph these. And we have a slope here of -4/3. Lastly, we have x minus y equals 0. We're going to subtract x from both sides. That gives us -y is equal to -x. And divide both sides by -1. And that's going to give us y is equal to a negative divided by negative is going to become a positive, and it's just going to become x or 1x. So the slope here is going to be 1. So for these, where you have it in standard form, you just have to follow these steps to get the y by itself, so you can read off the slope that's in front of the x. All right, hopefully that helps you. Let me know if you have any questions, and we'll see you next time. Bye!